Stage, Whitney? I know, okay. Anyways, there is Whitney over there. She's absolutely amazing person, really. I met her like 4 or 5 years. She's one of the smartest, brightest, fastest learners I ever met.
Why does she work with you?
And she's absolutely amazing on stage. I'm really, really privileged to call that person a friend.
Whoa.
Yeah.
You never compliment me. This is what's
There you
coming
go.
next. Yeah.
It's emotional.
This is a shit sandwich coming up, eh?
And then
Right?
there is Tim. Do your stuff.
All right. So obviously we are very flexible and very creative, and that's why some of these moments just happen. So up next, it's not often that one MC can introduce the other MC for the security showdown, a role play on Kubernetes security. And the only thing that I have left to do is actually just give a warning. The following awesome presentation contains slides with flashing images for storytelling purposes. Any events described may or may not be fictional. With this, the stage is yours. And, ta-da, Ozzie.
I'm just Ozzie, super duper engineer, extend. It's my life to write YAML again and again and again and again. People love it when I break out in song during the workday, especially since I'm the best engineer in this co-working space by a lot. I work for Big Corp, and I'm kind of a big deal, but I'm sure you already know that. Big Corp sent me to Cloud Native Days Romania last year, and I'm still wearing the same t-shirt. If you're wondering what that smell is, it's because I haven't washed it yet. There's a reason. This t-shirt is giving me good luck. There have been no security incidents since I've been back. Actually, wait, the t-shirt is not what you're smelling. It's my lunch. I've been microwaving fish again. I get so many compliments here, like...
Oh God, is Ozzie microwaving fish again?
That smell lasts for days.
I know, thanks. What's that? You're all into Kubernetes. Let me show you the perfect Kubernetes cluster that I built myself. I'll teach you a few things. Behold, Ozzie's production cluster. We've got Big Corp workloads running live, and frankly, it's flawless. I built it. I don't know what everyone is going on about. Kubernetes isn't that hard. Listen and learn, I'll tell you. I've moved all our Big Corp microservices into containers. Lift and shift, baby! These are run as pods. You can see them as app. I put it down as app for you plebs. At the bottom of the cluster. I've set up services to manage the networking between our apps so they can talk to each other. Big Corp already had a huge surge in demand. We've scaled to meet the needs, obviously. HPA! Everyone in this co-working space is so lucky to have me here. I'm the perfect engineer. You know what? I need to go talk with management. I deserve a huge promotion. You wait here. I'm gonna go talk on the phone loudly next to someone so that they know how important I am. Not that they wouldn't know that. I'm sorry, do you mind?
Oh, excuse me. I'd hate to bother you, sir. Hello, I'm Nova. I work here in this co-working space too, and I'm really sick of that Ozzie guy walking around here like he owns the place. He needs to be brought down to earth, am I right? And I'm the one to do the job. You see, I look pretty friendly, and I really am deeply kind. Like, I buy my friends lavish, thoughtful gifts with the money I make stealing from people in co-working spaces like this one. People really should be more careful. So I come in here and I pretend to be working, but basically what I'm doing is I'm watching people. And sometimes I see someone who walks away with leaving their computer unlocked. I have this tool called a rubber ducky. It looks like an innocent USB flash drive, but to the computer, it's a keyboard typing at superhuman speeds. I'm going to plug it into Ozzie's computer and cause some trouble. So I'll tell you exactly more about all that I'm doing with the rubber ducky later, but in the short term, let's do something to mess with him. I'm going to use Ozzie's credentials to commit a YAML change so I can run my workload on his cluster. Then I'm going to take away Ozzie's cluster admin RBAC privileges so he can't easily stop my running application. RBAC, or role-based access control, is used to define what a user can and can't do on a cluster. So I'm going to pull up my app in his browser. Great. Now I'm going to lock his computer. Oh my God. Look at this guy's lock screen. He is something else. Oh my God, I have to get back to my computer before someone sees me.
Yeah. Okay. So management said they're gonna call me back later because they're busy right now. Okay. Yep. Damn, I look fine. Wait, what? Nova rules? Ozzie rules? Wait, first of all, that's not true. The pillow was already wet before I went to sleep, okay? And why is that URL pointing at BigCorp? Oh no. Oh, Nova has somehow accessed my BigCorp cluster. I know about this guy. Some fool got hacked by Nova the other day. All the engineers in the co-working space were laughing at them for weeks. Apparently, Nova got some pictures of them, and they transferred Bitcoin to Nova. They transferred Bitcoin to Nova's wallet, and Nova's still asking for more. I mean, if they had a photo of me, who wouldn't want that? There was an investigation here to find out who Nova is, but no one found out the guy wearing a dark hoodie and an anonymous mask. I have to hurry up. I need to fix this cluster before anyone sees this website. Shoot, I'm getting an error. I don't have permissions to delete the workload Nova created. The error message looks like my RBAC permissions have changed. That's super weird. I gave myself full admin privileges. I mean, it's me. So I can do whatever I want on this cluster. What's changed? Oh yeah, luckily I've got an offline kubeconfig file, which also has full admin privileges. I store this safely on the USB key that I have in my wallet, right next to my photograph. Damn, I'm fine. Okay, here's the USB key. Let's plug it in and use the. Let's plug in the USB key and switch the kubeconfig file. Okay, great. I've got cluster admin access again, as it should be. First order of business: delete Nova's workload. Who rules now? If Nova has sights on me, I better try harder. Now that I'm back in the cluster, we should probably harden it to keep Nova out. I should probably have a more secure way of storing this backup account rather than storing into my wallet next to my lovely picture. We should make sure we know who can access it and when. Guess this is better than the time I had a sticky note with my computer password. Okay, I'm going to use a secret manager to store this securely, but equally having this offline in a literal safe, making it physically secure, could be a good option too. Okay, let's update the RBACs. So instead of having most privileges, I have least privileges when I connect to the cluster with my normal Ozzie account. Enough to do the work that I'm supposed to do and nothing more. Now that I think about it, the Cube API probably shouldn't be available to everyone on the public internet. At BigCorp, we already have a strong security in place to control who can access the internal networks of our cluster via our cloud provider. So using my cloud provider, I will put the Cube API server onto the private network, so randos can no longer access it. That's done. But damn, I lost my old way of working. How do I manage the cluster if I don't have direct access to the Cube API? My Ozzie account only has view-only access now, but I want to delete, create, apply, patch my workloads. I think I'll use GitOps, maybe the way to go here. I've heard a lot of people using it. There's some YouTube guy talks about this. I can put all my YAML into a Git repo, and then I can use GitOps to monitor that repo for any changes to the cluster. CNCF GitHub tools like Argo CD and Flux can help me with this. Yeah, the GitHub tool will be the one interacting with the Kube API to deploy all the company's workloads. Yeah, but how does this help here in a security context? I can grant GitHub tools access to have it manage updates to the cluster via the Kube API. Instead of humans using kubectl to make changes, my GitOps tool can make the changes. They compare the desired state in Git to the actual state in my cluster and bring them into sync. So now no one should need direct access to the cluster except privileged people and only in emergency situations. Awesome. We've improved the cluster security by locking down the Kube API. Now, if someone wants to attack my cluster, they will need to compromise my Git repo. Next, let's scan the cluster with Kubescape. Okay, Kubescape is a CLI tool that scans clusters, YAML files, Helm charts, detecting misconfigurations, and giving recommendations. I'm going to look into these results now to see if there is anything else I can improve on my cluster. I don't know why everyone is so scared of Nova. Oh, yeah, of course, I do know why. They're not as awesome as I am.
I wonder what's going on over there. I've been watching the Ozzie Jules Big Corp website in my browser. Looks like Ozzie took it down. That sucks. That means I lost a bet. I swore he'd have it up for at least 24 hours. Let me tell you what else I'm up to over here. So remember I used that innocent-looking rubber ducky hot plug to interact with Ozzie's computer? Here's what I did exactly. First, I made a copy of his kubeconfig file, so now I know the IP address of that cluster he made and he won't stop talking about. And actually, since I have his IP address, maybe I could put my website back up if his Kube API server's public. Hold on. Since I know the IP address of Ozzie's cluster, I can use this software Nmap to scan the ports and, oh, this tells me he made his Kube API server private. Bummer. Well, that's okay. I still have a lot I can and I will do. So back to the matter at hand, with this rubber ducky hot plug, I was able to get that IP address, also Ozzie's private SSH key. Now I have his identity. I also got his SSH config file, so I know where Ozzie's private SSH key can be used. And I took his Git config files, which shows me all of the URLs to all of the Git repositories that Ozzie's committed to lately. With this information, I can make Git commits as Ozzie. I intend to cause him so much pain.
Nice. The CFO is calling me, probably about that promotion I deserve. How am I going to spend all this money? Maybe I'll switch from microwaving fish to microwaving lobster. Yeah, hello? Yeah, Ozzie speaking. Yeah. No, wait, no, what? Wait, our product that's retailing for 100 euros is now being sold for about 15 euros. But we're losing money on every sale? No, that cannot be right. I built the cluster myself. Okay, I'll fix this mess. Okay, let me pull up the finance spreadsheet. We're selling our $100 product for $13.37. This is a disaster. What kind of idiot, rookie co-worker of mine changed the price of our product? Bloody noob. Let me check the Git commits for the payment service. Wait, it was me? I didn't do that. I didn't change that code. I've been here all this time. You've all seen that. Here is my commit code. That sets the value to 1337. Someone must have stolen my identity. Let me revert the commit. If only I could remember how to revert a commit. Okay, I'll get Copilot to do this for me. Okay, great. That's how I do it. That looks okay, right? Yep.
Nope.
Be quiet. I'm in super serious situation here, you know? Some of us are working hard while you're hardly working. You're probably thinking of dances on TikTok over there.
That's right. Don't mind me. I'm just flossing.
Wait. Someone just reverted the revert I just reverted, and the price is back to 1337. How did I set up access to my Git account? I made sure I was secure and used the private key that's only on my machine. But how would someone have access to my private key? I have to stop any future commits. This is bad. Okay, first step, I will revoke my SSH key and generate a new one. All right, let's revert that commit again. But this time I'm going to sign this this commit with a git sign. Now let's inspect the commit. That looks good. With git sign now, anyone who wants to make a commit will have to authenticate with OAuth, meaning even if someone steals my private key, they will also need to log in with Big Corp SSO provider. The TLDR for all of you noobs is that git sign provides an extra layer of security. And now I'll have the last laugh instead of Nova. I mean, he is a good hacker though. Okay, let's check the spreadsheet. Back to $100 and we're okay again. Whew. Okay, must be 5 o'clock somewhere right now. I wonder if any beer taps are open yet. Where's Victor? Okay, now that we've seen how hackers can cause havoc, this shows how important it is to secure your Git repos. If someone has my password, they could add a random key and commit as me again. This is why we've also built in multi-factor authentication. That way, to gain access to the repo, people will need access to my MFA device in addition to my private key. I should have set this up a long time ago. I guess I was just too busy thinking how good I am.
Wait, what? Back to me already? Ozzie wishes. I'm running circles around that guy. Ozzie's about to notice that the cluster is running some unknown container image for his message queue instead of the company-approved one.
Why is my cluster running some unknown container image for the message queue instead of the company-approved one? Oh, that's weird. Our messaging system seems to be working just fine. There haven't been no health status alerts. This must have been another commit earlier on. It looks like that image is being pulled from an unknown registry of the public internet. We host all our images on our internal registry. Why would this image be coming from some random registry? Let's run a kubectl describe on the message queue service to check the details. Looks like the image name is Nova images generic messages queue up 30 Nova. All right, let's see if this message queue is doing anything suspicious. I can see that the data is being sent to an unknown web address. This address is definitely not a Big Corp endpoint. Oh, bugger. Oh no, Nova's nefarious message queue app is sending a copy of the information outside the cluster. It's been quietly collecting customer data this whole time. Ah, crap. I underestimated Nova. And maybe I overestimated myself. Nah. I mean, of course not. I'm awesome. Still, let's figure out how to fix this. I'll add Kubernetes network policies to ensure that the message queue isn't allowed to send data outside the cluster. Here's what the message queue app should be doing. It should be taking requests from our website app and passing it to our database app instead of the cluster, inside the cluster. There is no reason that any part of the message queue should be sending data out of the cluster.
So Ozzie's been distracted with prank websites and his product prices changing. I've been doing my real money-making attacks. This whole time, the real hack has been running quietly in the backgrounds. The company message queue has been running my image, my music message queue app instead of the company-approved one. I've been running a background data pipeline, and it's been streaming customer data to me ever since it launched. And I'm going to sell it for big money. Money, 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 money. Wait, the information stopped being sent. Shoot. Ozzie must have put Kubernetes network policy in place. As much as I hate to admit it, Ozzie's starting to get better at Kubernetes security. Lucky for me, Ozzie didn't notice that other container I put into his cluster. I still have one more big trick up my sleeve.
Okay, we protected the cluster with the network policy. Next, let's fix this message queue. We all restored the Big Corp message queue by rolling back the changes. Can I do more to prevent these type of attacks? I've clearly defined which apps in my system are allowed to send egress traffic, which is not the message queue app. But I can do better than that. What if someone got access to the network inside of our cluster? Could they hijack network calls between pods? It'd be good to make sure we are not using plain text data transmission and instead have encrypted communications. You know, for you noobs, it's like how HTTPS is used to prevent snooping on internet traffic. I'll add a service mesh like Istio, Linkerd, Kuma, or Cilium. A service mesh, I'll explain this for you because I'll have to. A service mesh is used to set up a network inside of our clusters. And it has some additional features that we didn't have before. We can encrypt all traffic between the pods so that internet traffic can get intercepted or inspected. The internal traffic, actually. You should have caught that. A service mesh can also offer authentication, providing identity between services. Having this encryption plus identity feature is called mutual TLS, MTLS. A service mesh also helps to automate certificate management. A service mesh also adds fine-grained network policy and also network observability. This is great. Now I've protected my service-to-service communication by adding a service mesh. I mean, how awesome am I? How can we prevent Nova or any bad actors from making unwanted changes to the Kubernetes cluster in the future? If someone can access the Kube API, they can run any workload they want. This is how Nova made changes to our messaging queue. Let's see about using a cluster-level policy tool like Kyverno or OPI Gatekeeper. These are policy engines that work directly with Kubernetes built-in admission controllers. Using these tools, we can add organization-specific rules about what is allowed or not allowed by the Kubernetes cluster. Let's start by making a rule that prevents images from being downloaded from public image registries. Instead, images must come from Big Corp's internal registry. So now Nova won't be able to inject malicious workloads into our cluster. Yeah, and done. Whew, I'm glad that there will definitely not be any more problems with my cluster in the foreseeable future.
Excuse me, sir. Pardon me. There's a big red flashing fail sign on your
I'm sorry. No,
laptop?
no. You clearly do not know how dashboards work. I mean, it's supposed to do that, okay? You stay there. Now leave me alone. I have very important work to do. Wait. The policy that I just added notified me that there's a problem? The new policy is alerting about another image being used in the cluster. There must be another image. It's coming from a registry that is outside of Big Corp. What image is triggering this alert? Nova images, generic build-up 1.3. No!
Shh! Please keep it down. I'm trying to work.
You're always asking me to be quiet. Please stop taking speaker calls right next to my desk. Stop blasting Nickelback. I'm trying to work here. My delicate ears. Why don't you mind your own business and get back to your TikToks and trivial work? Some of us have important things to do. Okay, so how did Nova beat me again? I guess I really do have a lot to learn from Nova. Is it weird to say I actually kind of admire him?
Did you hear that? Did Ozzie just call my work trivial yet again? And he keeps assuming that Nova is male just because he is good at hacking? Forget ransoming stolen data. I want Ozzie to pay. Here's what we're gonna do. When I was still able to commit as Ozzie into Ozzie's Git repo, back before he set up multi-factor authentication, I started running my own container that was disguised to look like Ozzie's company's build service. That's what's causing his alert right now. It's a common rookie mistake for orgs to give their build services extra privileges, and I'm going to use my trivial skills to exploit this mistake and ruin him. I'm going to make sure Ozzie's entire career is trivial. Ozzie isolated his build service in the CI/CD namespace of this cluster. Let me show you. Here's that build service in the CI/CD namespace. Ozzie already had measures in place to isolate this namespace from others. He thought that would prevent attack. That's hilarious. So from my privileged running build service container, I'm going to use a tool called nsenter to break out of the container's Linux namespace and into the host namespace. Now I can run commands on the host server and gain access as root, and now I can see everything on the entire machine.
Okay, back to that image that triggered our policy alert. Nova Images generic build app 1337. Wait, 1337 is a hacker term for elite, as in elite? Nova's making me look like a noob right now. Let's look at what is being run. Okay, not only is Nova running a build service container, Nova has given a number of extra privileges to that container, including root permissions for the host machine. But thinking about that, if Nova runs a container with privileges, I'm pretty sure he would be able to move laterally onto the machine running the containers. If that's the case, I'm not in a great shape right now. We need to do something to fix this pronto. Right, let's update our runtime policies to make sure our rules around what is allowed to happen at the kernel level. The kernel is not managed by the Kubernetes cluster, but if someone had access to the kernel, they could track what is going on in the Kubernetes cluster. Runtime policies can prevent bad actors from elevating their privileges or moving laterally on the machine. So let's add a runtime security tool that uses eBPF, a tool like Falco or KubeArmor. With one of these tools, I can monitor all communications happening on the kernel and enforce policies at runtime. eBPF is a technology that allows code to run in the Linux kernel without changing kernel source code or loading kernel modules. eBPF gives us a lot of power, but as we all know, with great power comes
Great responsibility. Here I am. I have access to the whole machine in Ozzie's cluster as roots. Let's see if I can listen in on any of the traffic going across the network. The traffic's all encrypted, drat. Ozzie must have added service mesh. Dang, he's getting good. So here's what I'm going to do. I'm going to use my own eBPF-based tool called BoopKit. With eBPF, I can see and manipulate what's going on in Ozzie's cluster at the kernel level, which, as a side note, BoopKit was created by Chris Nova, a cloud-native security researcher, a wonderful human and friend. She inspired my name, but she used her hacking skills for good, not for evil like me. Right, so I think she'd approve me taking Ozzie down, though. Anyway, right, I'm going to use BoopKit so that I can mess with Ozzie's running kernel. Usually, the first thing I would do is to use BoopKit to see system calls on Ozzie's Kubernetes node. Normally, I'd look for some data here that I could sell or hold for ransom. But Ozzie, this is personal. Let me show you what trivial work your male antagonist is up to over here. I'm planting a fork bomb. So a fork bomb is a bash function that gets executed recursively. It's literally the characters that are up on the top of the screen there. It's a denial of service attack where the process continuously replicates itself and depletes system resources and crashes the system. This is what you get, you egotistical, male pronoun assuming, nickelback listening, fish microwaving, sloppy Kubernetes operator. Take this, Ozzie! Wait, what? It didn't work? Oh no, I just lost access to the cluster? I didn't have enough time to run my fork bomb. Oh no! Oh, no. Looks like I'm completely shut out. Dang it.
There.
Thank you.
Who is being loud now? Okay, so here's what happened. When I was planning to add Falco onto the node, I noticed that something didn't look right. Immediately, Falco alerted about other kernel activity. I was worried Nova might have been updating things at the same time. I alerted Big Corp Security, and we put plans together to quarantine the cluster. The engineering team provisioned a new cluster. This new cluster contains everything we've put in place over the last 27 minutes and 52 seconds. We've also redirected all customer traffic to the new cluster. Nova, in the meantime, will be seeing a big fat access denied. Since we still have the old cluster in quarantine, we can use forensics to see how Nova infiltrated the system. The best part is, we have a brand new cluster with hardened security.
Ooh, can I tell them about the security features of the new cluster?
Sure. How do you know what I'm doing over here?
Don't you worry about it. So first of all, Ozzie's Kube API is no longer public. It can only be accessed from within Big Corp. Then Ozzie also used least privilege RBAC. So there's one heavily guarded privileged cluster admin accounts that's only to be used in break glass emergency scenarios. Regular users have view-only access. But if they can only view the cluster, how do they run anything on the cluster? Well, that's happening with GitOps. GitOps is the tool now that's interacting with Kube API. So this moves the threat boundary out to the Git repo, and therefore we add additional things to secure Git itself. Things such as multi-factor authentication aided by GitSign. Next up, we talked about Kubernetes network policies. Ozzie specifically added this so I couldn't send data from inside of his cluster to outside of the cluster, but network policy can be used to restrict all sorts of network access. Then Ozzie added service mesh. Specifically, he added it to get the security benefits, MTLS. MTLS is a way for pods or workloads to have identity, to authenticate each other's identity, and then to encrypt the traffic that goes between workloads. Then Ozzie added cluster level policy. You can do this with OPA Gatekeeper or Kyverno. Now it's native in Kubernetes with validating admission policy. So this is used to make organization specific policy. Ozzie used it to make sure that images could only be pulled from the internal company registry, not from outside registries like mine. Then he added runtime policy like Falco or KubeArmor. He used these to monitor tool calls at the Linux kernel level, which is how he figured me out. Boo.
Okay, this was my cluster at the beginning. Looking back, I feel a little embarrassed that I thought this was a good idea. But to be fair, I didn't know 30 minutes and 23 seconds ago what I know now. This is closer to what a hardened cluster should look like. Although there's always room for improvement, I finally understand why people say good security is like layers of an onion. Every time we added a new tool, we added another layer of security. These layers are called defense in depth, allowing us to defend our cluster from a variety of attacks. Now, if any part of our system is compromised, they will be stopped by the next layer of the security onion. Well, all this great security work and talk about onions has made me really hungry. I think I'll go microwave a burrito.
Yay.
Ta-da!
Okay. Do you want to introduce yourself?
Yeah, sure. So, Tim Marmo, you know me from emceeing. Connect with me, like also connect with Andreas. You know you connect with everybody, but feel free to connect with us. I'm only on LinkedIn. As I said, I'm too old to do social media.
Right. And I'm Whitney. Nice to meet you all. Thank you so much for having me out here in Romania. It's been such a gift to be here. Thank you to the organizers and everyone who worked hard to put this on. Please do connect with me on LinkedIn. I'm mainly just on LinkedIn. And I'm a senior technical advocate at Datadog. And I'll be around today, so please do say hi. Thank you so much.